Hello my dear students, I welcome you to NEET World. So in this session, we will be discussing chemical reactions and equation NCERT exercise questions. Okay. So in the last session, we have covered first 10 questions of this NCERT exercises, and next we will be doing the next remaining questions in these sessions. Okay. So we have discussed about these questions already. So let us start from the class where we have stopped. Okay. So this question up to till this question till here we have discussed in the last class. Okay. So in this session we will be discussing the remaining things. So why are decomposition reactions and reactions are called opposite of combination reactions? Yes. So we have discussed clearly about decomposition reactions as well as combination reactions. Okay. So let us take one generalized example for decomposition reaction and we will discuss here. Look here. So what happens in decomposition reaction? For example, AB is a compound. Okay. Now this upon heating, what happens? It will gives the ion like substances, compounds from this particular compound like A, B. So it is decomposed now. So AB is separated here. Now look here. Let us say I have element A and element B. Now these combining to form a molecule or a compound AB. Okay. So now how these two reactions are looking? So one is in the first reaction it is decomposing, in the second reaction it is forming, combining. So how they are opposite to each other. They are opposite to each other. Now the decomposition reactions are those in which a compound breaks up into two or more simpler substances. See, it is forming two simpler substances, two or more simpler substances are formed. On other hand, the combination reactions in which two or more components will combine to form a single product. Yes or no? So now how they are opposite to each other. Okay. Thus the decomposition reactions are opposite of combination reactions. Okay. I hope it is clear. Okay. The example for decomposition reaction is one generalized example I have given here, calcium carbonate. So this is a common example we will be seeing. Calcium carbonate upon heating gives calcium oxide and CO2 gas is released. Okay. So this is one of the example, and I will be giving you one more example here. You can see PCl5 I am taking. Okay. So I am heating this. Okay. Upon heating, so it will decompose as PCl3 plus Cl2. Okay. So one compound upon heating decomposing into two or more substances, two or more compounds. See, compound breaks up into two or more simpler substances. Yes. So this is what happens in decomposition reaction. I hope it is clear, right? So now tell me one combination reaction example. So here we can take H2 plus O2 gives rise to H2O. Okay. So in this reaction I am taking 2H2. So therefore two water molecules are formed here. Okay. So now this is what the combination. See, two or more reactants are combining to form one product, single product. So this is what combination reaction. So this is how you can understand combination and decomposition reaction and why they are opposite to each other, right? The next let us discuss about write one equation for each for decomposition reaction where energy is supplied in the form of heat, light and electricity. See, we know decomposition reactions like takes place in presence of either heat or light or in the presence of electricity, right? So now give some examples they are asking for decomposition reactions involving adsorption of heat. So whenever heat is involved in the decomposition reaction, so we can represent that heat as delta, and if decomposition reaction is taking place in presence of heat, we can say it as thermal decomposition. What is that? Thermal decomposition. See, zinc carbonate upon heating forming zinc oxide plus CO2 gas is released. Okay. So this is what decomposition reaction. Okay. Then next here decomposition reaction in presence of by absorption of light or in presence of light we can say. Okay. So this light we can represent with some h nu frequency. Okay. So H2O2 hydrogen peroxide in presence of sunlight it decomposes to water plus oxygen gas is released. Okay. So here oxygen gas is released. Okay. Always remember hydrogen peroxide decomposes to like H2 water plus oxygen. Okay. Then next decomposition reaction in presence of like electrical energy, okay, or in the by absorption of electrical energy. So this is what electrolysis process. What is that? Electrolysis process. See, alumina Al2O3 upon subjecting to this electrolysis process. So what happens? It forms aluminium and oxygen gas is released. And we also discussed about decomposition of water in presence of electrolysis. Water, so upon upon subjecting to electrolysis, this we have discussed in our class now. So electrolysis. So what are the products formed? So at anode oxidation takes place and O2 is released, at cathode reduction takes place and H2 gas is released. So this is what happens in the electrolysis process. I have shown you everything clearly when we discussed in the class, right? So you can watch that if you haven't seen those discussion. Okay, now we also discuss decomposition in presence of light. We can call it as photolysis process. What is that? Photolysis process, where I have explained AgCl or AgBr. Okay, so these decomposes as Ag and Br2, right? Ag and Br2. So this happens in presence of light. So we can say it as photolysis process. Okay, so this is about 3 formats: decomposition reaction in presence of heat, light, electricity. Let's move further. Okay, what is the difference between displacement and double displacement reactions? Write the equations they are asking. So displacement, here one element will displaces the other from its solution. For example, see chemical reactions in which one element takes the place of the other element. So what happens here? See, copper sulfate is there. So the position of copper here, this copper is now displaced by this zinc. So zinc is taking the place of this copper and copper is coming out of it as a Cu. Okay, so now see, zinc sulfate, it is in the product side and here it is copper sulfate. So what is the difference we are observing? The zinc is taking the position of this copper. That's it, no? So this is what happens in the displacement reaction. Okay, what about double displacement? So here those reactions in which 2 compounds react to form other 2 compounds. Okay, here only one compound is formed. In double displacement 2 other compounds are formed by mutual exchange of atoms or group of atoms. Okay, for example, barium chloride we have, here we have sulfuric acid. Okay, by exchanging this hydrogens and this barium, so what we are getting now? By exchanging this barium we will get barium sulfate. Okay, by giving this hydrogen to this we will be getting HCl. So what is this? By exchanging of mutual exchange of elements will give some other new products. So this is what we will observe in double displacement reaction. I hope this is also clear, right? Let's move forward. Okay, so what happens? In the refining of silver, the recovery of silver from silver nitrate solution involving displacement by copper metal. Write down the equation. So what is that? Silver nitrate, AgNO3. Okay, so AgNO3 means nitrate will be having -1 charge, silver will be having +1 charge in this species, in this compound. Okay, now this compound upon treating with copper, so we know copper is more reactive metal than this silver, therefore copper can displace silver from its solution. Okay, so this is what the displacement reaction only. So this process is used to extract the silver from its its compounds. Okay, now what happens? So this copper will displace silver from its solution and we will be getting Ag. Okay, along with this copper nitrate is obtained, copper nitrate, NO3 twice. So if it is taking twice, we can take this is 2 times and here also it is 2 times. Okay, I hope this is clear without any confusion, right? So everything is going well, right? Then we have few more things to be discussed. Okay, what do you mean by precipitation reactions? Explain by giving example. Okay, so reactions in which precipitates, see, the reaction in which precipitates are produced are called a precipitation reaction. It means a solid mass is formed. For example, during the initial stage of this reaction, we are adding AgNO3 aqueous solution to barium chloride, which is also aqueous solution. So when we mix them both together, both are in the liquid state, aqueous solution I am saying, so liquid state. So after completing the reaction or during the reaction, some amount of precipitate is formed. It means solid substance is formed in the solid state I am saying, na physical state here both are in the liquid phase I am saying, but product side it is solid. So that is what AgCl is formed, which is in solid form. So now whenever we have some precipitate or solid substance is formed, we can indicate with the downward arrow. It means it will be like appears at the bottom of the test tube. Generally we can call it as precipitate. Okay. Now BaNO3 is again in the aqueous solution. So you have seen one precipitate during the reaction, right? So those reactions are considered as precipitation reactions. Next, sodium sulfate, okay, reacting with barium chloride gives barium sulfite. Okay, barium sulfate. So here also this is solid mass substance is formed, so which is appears at the bottom of the test tube, right? This is also considered to be precipitation reaction. Okay, along with that silver chloride, sodium chloride solution aqueous form is formed here. Okay, though these things are what precipitates during the reaction. So therefore these two reactions are considered as precipitation reactions. Okay, in any chemical reaction, if the solid mass, the precipitate is taking place, we can consider them as a precipitation reactions. Okay, and explain the following terms of following in terms of gain of electron, gain of oxygen and loss of oxygen with the two examples each. So for example, oxidation means what? Oxidation. So it means addition of oxygen is called oxidation. They are saying in terms of gain and loss of oxygen only. So gain of oxygen is called oxidation. For any species, let us say A is a element. To this, if you are adding oxygen, okay, if you are adding this oxygen and let us say it is forming AO2 compound. Now see, A is getting getting added with this oxygen. So A is called oxidized product. So here in this process it is A is oxidized. What I am saying, A is getting oxidized and forming its respective oxide like AO2, right? Now see, sodium is there. Upon treating with oxygen, forming sodium oxide. So sodium oxide means oxygen is added, na Na2O is formed. Okay, so this is nothing but oxide of sodium. So I can say this is oxidation process. Okay, similarly copper, upon adding oxygen, forms copper oxide. Okay, so this is also what? Oxidation process. Okay, I hope this is also clear, right? Now what do we mean by reduction? So they are saying to define in terms of loss and gain of oxygen only. So reduction means it is opposite of oxidation, you can define. So how can we define? Like oxidation means gain of oxygen we are saying, right? So reduction means loss of oxygen or removal of oxygen. So now from copper oxide, if we treat with hydrogen, so it is forming copper plus H2O. So copper oxide is converting into copper only. So this oxygen is lost or oxygen is removed from its oxide form, right, for the copper. So I can say copper oxide is undergoing reduction. So which is undergoing reduction here? Copper oxide. Copper oxide is undergoing reduction. Okay, undergoing reduction you should say. And what about hydrogen? I can say now H2 is undergoing oxidation. Okay, I hope this is clear. Okay, here also zinc oxide is converted into zinc. It means, can I say zinc oxide is undergoing what? Loss of oxygen. So it is reduction. Zinc oxide undergoing reduction and forming zinc. So this process is called a reduction. Okay, I hope that is clear. And the next here copper is getting converted into copper oxide form, right? So can I say addition of oxygen to this copper is taking place during this process. So I can say copper is getting oxidized. Okay, so during a reaction, okay, if loss of oxygen is taking place, then you can say reduction. If gain of oxygen is taking place, you can say oxidation. Okay, if both processes are taking place in one single reaction, you can call those reaction as redox reaction. What is that? Redox reaction. I hope it is clear, right? Okay, let's move further. A shiny brown colored element X upon heating in air becomes black in color. What is the name of that element X? And the black color compound formed and the black colored compound formed is, see, we know this copper is there now, so when it is exposed to oxygen, so it will form CuO. Okay, what it will form? CuO. Okay, so this Cu, a shiny brown colored element. Yes, copper is shiny brown color element only now, so X is copper. And what is the like color in black? Like when it is exposed to air, what happens when it is heated with air? So what it is forming? A black in color oxide forming, so that is nothing but copper oxide. I hope this is also clear, right? Let's move further. Here, why do we need to apply paint on iron articles? Yes, why do we need to apply? So when we apply paint on iron articles, so it will avoid the direct connection with the atmosphere. I mean moisture which is present in the atmosphere. That metal surface will be now having no connection with the atmosphere moisture, right? Therefore it will prevent rusting. What it will prevent? It will prevent rusting. So let us see. We apply paint on the iron article so as to prevent it from rusting. Okay, so when the surface of iron is coated with some paint, its surface area does not come in contact with the oxygen and the moisture. Okay, therefore rusting does not take place. Okay, so this is why it is important to paint any iron articles if it is placed in any of this direct explosion. Okay, so to avoid rusting and to get more lifespan of that particular iron article. Okay, so that is important thing. Okay, so now for example, if iron is exposing, what happens here? When iron is exposing to oxygen and also water, moisture present in the atmosphere, so what happens? It will form iron oxide Fe2O3. Okay, dot XH2O is formed. So this is nothing but this is a formula of rust. What is that? This is a formula of rust. So rusting is what process now? So rusting is what? Oxidation process. Oxidation process. Iron is converting into iron oxide. So rusting is oxidation process. Okay, let's look into little more deeper. So oil and fat contains food item. Okay, oil and fat containing food items are flushed with nitrogen gas. Why? Okay, so where do we see this in our daily life? Yes, if you are look into the chips packet, there will be many chips packet in our market now. So generally chips packet will be filled with a lot of what? Gas. So that gas is generally nitrogen gas. So what is the use of filling nitrogen gas in that chips packet? So it will avoid oxidation process of that chips, whatever the food material we have, whatever the oil material, fat material it has, so that will be not get into oxidized form easily. Okay, so let us see here. Oil and fat contain oil fat containing articles are flushed with nitrogen to prevent them from the oxidation. Okay, so this will protect them from becoming rancid. So rancid means what? What is mean by rancidity? When fats, oils are exposed to air, they get oxidized and become rancid. Okay, and their smell and color changes. This phenomenon is known as rancidity. Okay, so this oil or food material, like oil food materials, like fat containing food material, what happens? So the compounds get oxidized when it is exposed to oxygen. So in order to avoid this oxidation process, we are filling it with only inert gas, that is nitrogen gas. Therefore it will be avoiding the contact with the oxygen gas in the that lace or chips packet, whatever it is. Okay, I hope it is clear. So it is important to fill the nitrogen gas. Okay, what if we won't fill it? So the taste will become very bad, and also the smell and color of that chips will be getting damaged and it looks very dirty. Okay, so we cannot even able to take it. Okay, so now explain the following terms with one example each. Okay, corrosion. So corrosion means what? Metals are slowly eaten up by water or air or acids. Just now we have discussed in now. So when iron, see iron nail it is, so when it is exposed to water or oxygen present or moisture present, okay, so it will be forming what? Iron oxide, Fe2O3 dot X H2O is formed. Okay, so this is the like rust process or corrosion process here. Okay, then next, what about rancidity? So rancidity, food containing fats and the next oils kept for longer time acquires an unpleasant smell and taste. Okay, so what happens? Now when food is kept aside for longer time, when it is exposing to the normal atmosphere, so the food material, the oil materials present in that will get oxidized and gives very unpleasant smell, therefore it is not suitable for eating. Okay, so that is what the process is called rancidity. I hope everything is going well, right? So this is the questions from NCERT book. Okay, so our NCERT session is over. So in the next sessions we will be discussing how can we approach towards JEE and NEET using these concepts what we have learned from the chapter 1 of this 10th CBSE. How can we approach towards NEET, JEE and other competitive exams from this knowledge. Okay, so keep watching our channel NEET World. So let's discuss in the next session. Happy learning. Thank you for watching.